Boeing did the impossible. They eliminated the Airbus A350's biggest competitive advantage without launching a single new aircraft program. No new design, no new development costs. Just one quiet certification that changed everything. Here's what happened and why Airbus should be terrified. March 2026, Boeing is still dealing with the fallout from years of production problems, strikes, and regulatory scrutiny. The company has not launched any new aircraft program. It has not announced a next-generation narrowbody. It has not delivered the bold reinvention that analysts insisted Boeing desperately needed. Then, quietly, the FAA certified an update for the Boeing 787-9 and Boeing 787-10. No new aircraft, no billion-dollar development program, no structural overhaul. Just a certification for a capability that had already been physically built into the plane for years. Here is what actually matters. That certification just changed the economics of one of the biggest fleet decisions in commercial aviation. Every airline currently evaluating long-range aircraft needs to run the numbers again. The change is called IMTAO, Increased Maximum Takeoff Weight. It sounds technical, but the concept is simple. Every commercial aircraft has a maximum takeoff weight, the maximum allowable weight at the moment the wheels leave the runway. That weight includes the airframe, fuel, passengers, cargo, and catering. Everything. The limit is not arbitrary. It reflects what the wings can bear, what the landing gear can absorb, what the fuselage can withstand across tens of thousands of cycles. When Boeing designed the Boeing 787, engineers built the structural components with margin, beyond the original certified limit. Aerospace engineers never design to the absolute limit. They build in reserves. What Boeing realized, or perhaps decided to activate, is that the reserve already embedded in every Boeing 787-9 and Boeing 787-10 was substantial enough to certify a higher limit without modifications. The Boeing 787-9 receives an increase of roughly 10,000 pounds, approximately 4,500 kilograms. The Boeing 787-10 gains nearly 14,000 pounds, around 6,350 kilograms. Here is the genuinely unprecedented part. Boeing did not wait for certification before preparing aircraft for the upgrade. Every Boeing 787-9 and Boeing 787-10 manufactured since December 2025 already rolls off the line with the structural capability for IMTAO. Airlines do not receive this automatically. They choose when to activate it through certification with their own regulators. But the hardware is already there. Boeing essentially pre-installed an upgrade across its entire future production before the certification was even announced. When the FAA approved it, every aircraft coming off the line in South Carolina was already eligible. Air New Zealand has already confirmed it will be among the first operators. The real-world implications of those extra kilograms come in two forms. Airlines can carry more fuel, which means flying farther, or they can carry more payload, meaning more passengers and more cargo on the routes they already operate. Each airline chooses whichever trade-off makes the most sense for their network. The Boeing 787-9 with IMTAO gains approximately 310 nautical miles of range, reaching around 7,870 nautical miles. That is roughly equivalent to the distance from Sao Paulo to London or from Seoul to Los Angeles. Or, instead of flying farther, the aircraft can carry approximately 3 additional metric tons of payload on current routes. That converts to roughly 25 to 30 extra passengers in dense economy configuration. On a long-haul flight, those extra seats can represent more than $500,000 in annual revenue per aircraft at high load factors. The Boeing 787-10 gains even more in distance, approximately 430 nautical miles, reaching around 6,760 nautical miles. Or it can carry 5 extra metric tons of payload. Now, place those numbers in context against the Airbus A350. Before IMTAO, the Boeing 787-9 had a range of around 7,565 nautical miles. The Airbus A350-900 sits at roughly 8,100 with full payload. That gap of more than 500 nautical miles covered several major city pairs and gave airlines operating ultra-long routes a clear reason to choose Airbus. After IMTAO, the gap shrinks to approximately 225 nautical miles. That is the distance from New York to Boston. In aviation terms, where most intercontinental routes fall well below either number, that gap effectively does not exist for most airlines on most routes. To understand what Boeing just accomplished, consider what the A350 was supposed to be and what it was supposed to prevent. The Airbus A350 was never designed to be a slightly better Boeing 787. It was designed to be an entirely different kind of aircraft. When Airbus launched the program, the argument was clear. A category of routes existed, the very long ones, requiring superior range, payload, and fuel efficiency at high gross weights, where the Boeing 787 simply could not compete. The A350 was positioned as the answer for those routes. The A350-900 carries a list price of approximately $317 million. The A350-1000, the stretched version with range approaching 9,000 nautical miles, lists for around $366 million. Those prices reflected what Airbus was selling, a capability the competition did not have. The strategy worked. Singapore Airlines, Qatar Airways, Cathay Pacific, and Lufthansa, carriers operating some of the longest and most demanding routes in the world, built their future fleets around the A350. Qatar alone operates more than 60 of them. For routes like Doha to Los Angeles or Singapore to New York, the A350-1000 is not a preference. It is a requirement. But here's the problem. Those ultra-long routes above 8,000 nautical miles represent a fraction of the total intercontinental market. Most long-haul routes fall between 4,000 and 7,800 nautical miles. Routes between Asia and Europe. Routes between the Middle East and North America. Routes connecting Africa to the Atlantic world. On those routes, the A350-900 was the answer because the Boeing 787 could not reach until now. This is where the math gets uncomfortable for Airbus. The Boeing 787-9 has a list price of approximately $292 million versus the A350-900 at $317 million, a difference of $25 million per aircraft. Airlines rarely pay list prices, but the relationship between the numbers holds. The A350 commands a significant premium over the Boeing 787, and always has. That premium was justified by the capability gap. More range, more payload, better economics on the heaviest routes. With IMTA, that justification just got significantly narrower. Think about what $25 million per aircraft means at scale. An airline ordering 30 Boeing 787s instead of 30 A350s, assuming similar negotiated discounts, is looking at potential savings approaching $750 million before a single passenger boards. The comparison gets sharper when examining the Boeing 787-10. The list price reaches around $338 million, more expensive than the Boeing 787-9, but carrying significantly more passengers. On routes where both aircraft can operate, the Boeing 787-10's cost per seat is lower. With IMTA pushing range to nearly 6,800 nautical miles, the aircraft now covers an enormous slice of routes across Asia, the Middle East, and Africa. The economics favor the Boeing aircraft for any operator not crossing 7,000 nautical miles. Which airlines are running these calculations right now? Korean Air, ANA, and Japan Airlines are operating or expanding routes between East Asia and North America in the 5,500 to 7,000 nautical mile range. Vietnam Airlines and Indigo, as Indian carriers move into long-haul wide-body territory, are evaluating aircraft for routes fitting almost perfectly into the Boeing 787-10 sweet spot. Middle Eastern carriers renewing aging fleets. African Airlines wanting to connect Lagos or Nairobi to New York or London without a hub stop. For all of them, the Boeing 787 with IMTA now enters every conversation where Airbus used to be the default answer. The A350 is not finished. The A350-1000 with roughly 9,000 nautical miles of range sits in a category the Boeing 787 cannot touch. IMTA does not change that. Qantas's Project Sunrise, requiring approximately 9,500 nautical miles for Sydney to London, demands the A350-1000. Airbus spent years developing a specific modified variant to make those routes possible. The Boeing 787 with IMTA does not enter that conversation. Singapore Airlines operates the world's longest commercial flight, Singapore to New York, at over 9,500 nautical miles. That route exists because the A350 has modified fuel capacity and a structural envelope no Boeing 787 can match. There is also the question of cabin experience. The A350 has a wider fuselage than the Boeing 787, translating into a visibly different premium cabin product. For airlines where business class experience drives commercial differentiation, the A350 delivers something the Boeing 787 cannot replicate. But that market, ultra-long range with premium focus and range above all else, represents a relatively small slice of the total wide-body market. The volume is in the middle, and the middle just shifted toward Boeing. Airbus is not standing still. The company has been incrementally increasing the A350's MTOW over time. The A350-1000 that will operate Qantas's Project Sunrise has a higher takeoff weight than when the aircraft was first certified. Airbus understands the competitive value of pushing limits, but here is the structural challenge Airbus faces. In the 5,000 to 7,500 nautical mile segment, the segment including most transatlantic routes, most trans-Pacific routes from secondary Asian cities, and most Middle East to North America connections, the A350-900 competed primarily on range and premium positioning. The A330neo, Airbus's lower-cost widebody, does not come close in range or efficiency. There is no Airbus aircraft matching the Boeing 787-10 on cost per seat on medium to long-haul routes, now that the Boeing 787-10 has the range to serve them. Airbus could theoretically develop a response, a new variant, a new certification, its own structural update, but that takes time, certification cycles, and investment. Boeing just moved the goalposts on a program that costs almost nothing. A typical new wide-body aircraft program costs more than $20 billion to develop. Boeing activated this capability for a fraction of that. The engineering work was already done the moment the aircraft was built. The FAA certification process represents the only significant cost. The A350-1000's position at the top of the market remains unchallenged. Airbus holds that territory and will hold it for the foreseeable future. But that territory is not where most of the wide-body market lives. Boeing did not win this competitive moment by announcing a new aircraft. It won by certifying something that was already there, already embedded in more than 1,000 aircraft already delivered, and in every aircraft rolling off the factory floor going forward. Airlines sitting in fleet planning meetings right now, the ones that had penciled in A350s for routes that now fall within the Boeing 787's expanded envelope, have a more complicated conversation ahead. The A350 will keep selling, but the question of who buys it and for what just changed completely. That change did not cost Boeing $1 billion. It cost a certification.